Welcome back. The objectives of this video is to continue our studies of logarithmic function manipulation by showing you examples of a vertical dilation with the product property, and we'll also do a vertical dilation using the change of base. When graphing a logarithmic function, we can show that the power property is equivalent to a vertical dilation of the parent function. So let's take a look at this idea. In example 5, g of x equals log base 2 of x squared. We want to use the power property to show this is a vertical dilation of the function f of x equals log base 2 of x. So I've taken the liberty to graph or plot the points for log base 2 of x over on the right hand side in blue. So we've got our blue log base 2 of x. That's our original function f of x. Now this one we had log base 2 of x squared, so g of x equals log base 2 of x squared. We can apply the power rule. We can bring that exponent 2 down in front, and we get 2 times the log base 2 of x. Now we should know from our previous studies that the 2 is no longer bundled with the x, and that is going to be a translation along the y-axis. So in this case, we're going to have a dilation, a vertical dilation of 2. We're moving up along the y-axis. And sure enough, I've gone ahead and in red plotted the points for 2 times log base 2 of x. We still go through the point 1, 0, but at 2, x of 2, we have a y value of 2 instead of 1. At x of 4, we have a y value of 4 instead of 2. And at x equals 8, we have a y value of 6 instead of 3. So each one of these is 2 times higher than its previous one, than the original function f of x. So you see here, that's where our vertical dilation of 2 comes in. So finally it says describe the change in the output values over equal length input value intervals. So let's take a look at that. And in describing the change, we can say as x increases by 1 unit, the y values are a vertical dilation by a factor of 2. Thus our xy rule is x to y. In example 6, we're given g of x equals log base 2 of x minus 1. And we're asked to use the change of base property, log base b of x, which is log base a of x over log base a of b, where a is greater than 0 and a can't be 1, to show this is a vertical dilation of the function f of x equals log base 2 of x. So again, I've got f of x here plotted out in blue with those particular points. So there's our function with our key points of f of x, just like we've been doing. And connecting those, that gives us our f of x. Now, we could look at this as a shift along the x of 1 unit to the right. That I could see being the case here, but let's go ahead and take a look and apply the change of base as we're asked to do and see if that confirms what our theory is here. So in converting to base 10, we get log base 10 of x over log base 10 of 2, which is equivalent to 1 over log base 10 of 2 times log base 10 of x. Imagine like factoring the denominator out of g of x, and we end up with 1 over log base 10 of 2 over log base 10 of x. So in graphing the two functions, if I want to graph g of x, so I've done a little table of values here. When x is 1, our function, our original function log base 2 of x, our output for f is 0. When x is 2, our output for f is 1. When x is 3, our output for f is 1.58. When x is 4, our output is 2. But for g, when x is 1, log base 2 of 0 doesn't exist. So I put 2 in for x into g, and I get log base 2 of 1, which is 0. And the pattern is going to follow here that all of these are shifted down 1 unit, or for additional x, I'm shifting 1 unit to the right. So that does seem to hit our hypothesis that even using the change of base formula and plotting those points, it's simply a 1 unit shift to the right. So our new graph is going to, each one of these points is going to be, our x value is going to be shifted 1 unit to the right, and we get a graph. We'll have a asymptote at x equals 1, and that will be our function. The black one is g of x. So to describe the change in output values over equal length input value intervals, we can say as x increases by 1 unit, the y values are shifted to the right 1 unit. Thus our xy rule is x plus 1, comma y. And that wraps up these first two transformations of with a vertical dilation using the product property and using the change of base. And we'll get some more practice with this when I see you in class.